Good day, dear students. Let us start with our lecture. Next one. Good day. Are you all there? Hello.
Yes, sir.
Yes, sir.
Hello, sir.
Yeah. Good. Are you able to see the screen?
No,
No.
I think now we can see.
Respond.
We are able to see your screen, sir.
The PowerPoint.
Yes, sir.
Oh, but I'm something black is coming. Move this window. Oh, okay, right. Okay. This is the problem with Zoom. Okay, the window is coming here in between. It says I cannot minimize. Okay, dear students, good afternoon. Let us continue where we left off. Okay, some hypothesis and all we have to take and few examples. So decision making we will see. I hope everybody is there now. So this is decision making will be under uncertainty. We have to make some decisions when we are unsure. Examples like for selecting the school, which school to join when you're small kids, or even when you're grown up going to university, which university, UNAM, NAST, examples. Then marriage, then therapy in medical, some problem is there, which therapy to do, and jobs, which job to join. That will come from school only, which stream you're selecting, then you will think. But when you're applying for a job, different categories might come in that branches, depending on the experience and expertise and skills you have attained and whatever more. So this is about the decision making, which is very important in life. Research also, decision making becomes very important. This. So which topic to select and to decide, how is the outcome of that research, everything, data, is the experimental setup is ready, parameters you are following, all those things, variables, statistics. This will provide an approach to decision making under uncertainty. Yes, whatever the statistics you have that will provide to make you some decision. That is sort of decision that is making by choosing the same way or would it bet. So maximize expected utility will be there, subjective to which value, statistics, and then null hypothesis, general statement, or default position. It will be that is it is nothing with the new happening. So there will be no association between the or among the groups, or no relationship between the two measured phenomena. So this is about the decision making. Statistical hypothesis. This is called sometimes known as confirmatory data analysis. It is a hypothesis which is testable. That is on the basis of observing a process. It can be modeled. That is, you will be setting a variable, random variables will be there. Many variables you have to set up randomly. That is, and the main idea for this will be that is whether it is difficult to prove the fact that it is right, or and it is very easy to prove that it is wrong, right? Suppose you are writing a test or exam. When the examiner marks, he will have the marking scheme. If it comes correct to match to that, it will be right. If something wrong, then he will put wrong. As soon as he sees, he will know it. Oh, answer this. It looks wrong. Let me put wrong. That's it. So like that. But putting right is not easy until unless it matches. Example, in research also, it's like that. Until unless your data matches with the original published data which is there. As I gave you a few examples last week. Suppose I want to do benzene, benzene to cyclohexane hydrogenation. Now cyclohexane, these are all reported molecule, but I am changing the condition, I am changing the reagents and all. Right? So cyclohexane, I will see in the data, reference data, where it is coming, whether it is matching with my, what I got the result, then I will say right. So it will take time to prove it. It is difficult to prove it right. But when it is little bit wrong, then you will say wrong. Or it is totally wrong, easy, it's very easy to say wrong. So the reason for this is you have to find one counter example. In any field, this will be applied, whatever area, natural sciences area, biology or zoology or engineering sciences, everywhere this process involves, right? Then there are two types of hypothesis here. It is a null and alternative and null hypothesis. Alternative hypothesis is represented by H1. Null is hypothesis represented by HO. So H1 is hypothesis as main purpose of this study. It will be of the study, and hypothesis as opposed to purpose. What hypothesis you are doing upon that purpose, it will oppose. And alternative is that you want to claim it to be right, and hypothesis you want to claim it to be wrong. If you're getting a wrong answer, then it is wrong, right? When you're getting the wrong result in research and which is not matching what you needed, then it is wrong, right? So it is a way to induce contradiction after assuming null hypothesis is correct. You can't say null hypothesis will be correct. There will be a contradiction. Your result is wrong. Then you can't say correct, right? So it's like that. Suppose benzene to cyclohexane I'm doing, and benzene to I get some other thing, cyclohexene or cyclohexadiene. I want cyclohexane. That is wrong. So like it, sorry. So it's like that. So alternative hypothesis and null hypothesis. So you can't do the contradiction results. You can't say null hypothesis is correct. That will contradict it. It will be wrong. Suppose you're getting some result in research which actually you wanted just now. Just now I gave you the example, but you're saying no, this I got this. No, that's wrong. And as from the ethical point of view and plagiarism point of view, you will be caught in scientific community. They will not accept your results. So your results has to be true, proven, as I told you in the last lecture also. Then main idea of hypothesis testing, statistical testing, it is continued. So main idea, it is difficult to prove that a fact is right, but it is easy to prove wrong, which we did that just now, we had gone through. So the reason is that you only have to find one counter example we have to see. So H1, All students in conversion informatics classes, they are statistical experts. Let's set up the opposite hypothesis. So all students in conversion informatics do not know statistics. So you see this, then all students in informatic classes are statistical experts. In convergence, they do not know statistics. So our goal is to prove this proposition is true. So the evidence you have to find that is false in this null hypothesis, and the original proposition is true. So the first one is true, and the second one becomes false. Okay. Another example we can see. So H1, HO, the height of men and women is different. Our goal is to prove that this proposition is true. Okay. This, then HO, this is null. The height of men and women is the same, right? And we assume that men and women are the same height. So we can examine the height of men and women. So that is in order to find the mean and variance. So if we find the numerical evidence, men, women, they will have different anyhow, that they collected the data, original proposition is true. So remember, H1 is always, it will be true, HO will be false. You get the result, if it is true, you're right with H1. If you get the result, which result you wanted, if it is wrong, null. So remember these two basic hypotheses, which are very, very important in research with these few examples. Any more examples, if you come across, you can can go through, and we'll see this. This is a very good thing. The blind man and the elephant. This is an old story. So you see the blind man and the elephant, this taken from that section, 1816, 18. There are 6 men of Hindustan and to learn much inclined. So who went to see the elephant, though all of them were blind. So these people, all of them were blind, so that each by observation might satisfy their mind. First one. The second, the first person approached the element and happened to fall against his broad sturdy side, because he tried to touch that or climb, but he fell down, right? The first one, because it is a broad. So at once began to bawl, bless me, but the elephant is very like a wall, he's saying. He's saying it's like a wall. See the third one, the second one. He's feeling of the tusk and cried, oh, what we hear. So very round it is, smooth and sharp. To me, tea is mighty clear. So this is wonder of an elephant. So it is like a spear, he says, right? And the third one, he will approach the animal and happening to take the squirming tongue within his hands, he will try to take, and thus boldly up and spake, I see Koiti, the elephant is very like a snake. So that he will try to take that tongue, which is long one. He assumes it is like a snake. So these people are blind, but they are touching and seeing. Through that, they are observing. They are observing. They could make the decision. So this is a very good example. The fourth reached out his eager hand and felt what most this wondrous beast is like is might plain. Kuti, T is clear enough. The elephant is very like a tree, right? So he touched the knee, then he assumed that it's like a tree because legs are long, as we know. These people are blind. Then the fifth one, who chanced to touch the ear. He touched the ear, said in The Blandest Man, can tell what is the resemblance most. Deny the fact who can. The marvel of an elephant is very like a fan, he says, because as the ears are very big, and he thought it's like a fan. So that is how they could imagine by observing. The sixth no sooner had begun about the beast to grow, the sizing on the swinging tail that fell within his scope. I see, quoth he, the elephant is very like a rope. Yeah, the tail. He touched the tail, this sixth man, and he said it's like a rope. Then what? And so these men of Hindustan disputed loud and long, and each with his own opinion exceeded stiff and strong. So they had, each of them had their own opinion, which was very strong, very stiff. Though each was partly in the right and all were in the wrong, it says. So the moral so oft in this theological was the the disputants, I mean, rail on utter ignorance, it can be, or of what each other is meaning it, and the prate about an elephant. So none of them has seen because they are blind. They just observe it by reasoning, thinking it's like this. I think same it is coming, sorry. Oh, double it can. Okay, we can take from here. So in your table, groups discuss, following questions can be there, compare the similarities, differences in hypothesis as we have discussed, scientific theory and scientific law. I hope you understood the before one, the story of the elephant, right? So from that, you can imagine how you have to think in your research, right? As we have gone through hypothesis examples and these things, this elephant example, uh, men and women of same height, who is tall, who is short, right? Differences. So even when you're going through literature, you have to think, you have to observe, right? You have to read, then think, no, this can be done, this can be done. Once you start your research in laboratory, you will come to know many things, right? When you're doing the experiment in any area, you will get many ideas that time. But before that, when you have to write a proposal, you have to think everything. You have to decide on your topic, right? Which area you want to work. Okay. So let us go through that. Then we can discuss this later also with the different examples. So compare the similarities and differences between a hypothesis, scientific theory, and scientific law. Then this is statistics, test statistics, probability, significance. So test statistics, this is specific statistics tool that is chosen to test the null hypothesis. Examples, it could be included FTR, depends on what hypothesis you're going to test, what variables are there. So the obtained value, so the actual value obtained, that is applying the test statistics to the data of interest. So the probability value here associated, the obtained value is P. And the critical value of the test statistics, this is associated with the chosen significance level, that is R. So the obtained value here will be greater, critical value, and the result is significant, which is very important. Then hypothesis testing, 4-stage, it can be research hypothesis, it will be design, variable, statistical hypothesis, hypothesis testing, phase 3, and the final will be decision and interpretation. So phase one, research hypothesis, design and variables. So what is the state your research hypothesis? What is the hypothesis? You have to state that. You have to decide on the design based on your research problem, your hypothesis, and what you want really to do or to say. That is about your results. If you want to say that A cost B, you will need an experimental or time series design. If probable cause is sufficient, a quasi-experimental design would be appropriate. So you have to see what A is saying or B is saying. You have to design in that way, your research design. So it will be based on the research problem, what you have selected. So operationally, you will define your variables. One variable can have more than one operational definition. So one variable, it will be there more than one. So operational definition it will have. Phase two, statistical hypothesis. So consider your chosen statistical procedures. What procedures are there you have to choose. So you have to write one statistical null hypothesis. That is for each operational definition you're writing. Each variable that reflects statistical operations has to be performed. So phase two, statistical significance. So what is statistical significance important for business? So this is important, that will be giving you confidence, and that changes your website or app actually, that will have a positive impact on your conversion rate and other metrics. So numbers and metrics, they will change or fluctuate. That is from day to day. And statistical analysis, they will provide sound mathematical foundation, that is for making business and decisions and eliminating false positives. A statistically significant result isn't attributed to chance, and this will depend on two key variables: the sample size and effect size. Sample size and effect size. That is how much sample size it is, how large it is for your experiment. This is about sample size. The larger the sample size, the more confident you will be able to evaluate the results of the experiment, and assuming that it is a randomized sample. So if you're running this test on a website, so more traffic your site receives, so sooner you will have more data you will be getting. So that from which you can determine the statistical significant result. That is, you will run into sampling errors if your sample size is too low. So your sample size should always be large, right? If you have less sample, then errors will come. Suppose I told you the example of benzene to cyclohexane reaction with a catalyst I'm doing. I will be using that as a model reaction. I want to test whether that product I'm getting is 100%. So what I will do, I will change its parameters and I will conduct at least 10 to 12 experiments. So the data which I am giving, then I will evaluate it. Which is the best result giving. I will put that number one in that preference order, first, highest, next, like that. Whether in the last ones, if I'm getting positive or negative result, the best result, I will say this, with this reagent, I got this best, right? So it's like that, right? So somebody, suppose biochemistry people, antimicrobial activity they are testing. They will test on different varieties of organisms, right? They will take that, right? Staphylococcus or something, some other bacteria, 2, 3, they will compare and check antimicrobial activity. This compound is giving for this. They might change the ratio of that testing compound and the organism taken, or they may change the incubation period. Literature says 1 hour. Let me do 2 hour. What will happen? Let me do 1 hour only, different temperature, or let me do 45 minutes. Effect of time, you can study effect of temperature, like that, different parameter conditions. When you have large sample size, then it will be very good to evaluate in your results. So this will come, sample sizes you can study by um, going through literature. Suppose you selected some topic, like I told hydrogenation topic, this is benzene tricyclic. Then I go to the literature, I check how many substrates they are doing, how many variables they are doing. From that literature reading, you get more idea. And in that, you can put your new idea, you can add into it, so that your project will become excellent. So this is the way. Suppose if you take, I will say, no, let me do just 3, 4 samples or 3, 4 tests, finish. No, that will be too low. Samples with 4, 5, you can't decide your project, you can't end your project, no result you will get. So it will be a negative impact on your professor. You will have an, he will have a negative impact on him, right? So it's like that. So this is very important section. Okay, sample size and effect of size. Then you have decision interpretation. You have to decide here to make the decision. So for each research hypothesis, you have to consider the decisions, that is the statistical null hypothesis. So for each research hypothesis, you have to consider qualitative, contextual information relating to potential plausibility, whether it is correct or wrong. Then cautiously explain your findings. You have to explain, respect the research hypothesis list, and then you have to discuss the limitations. There to valid inference and references. So all this you have to do. Once you have the table, you have done the sizes, large sizes, you evaluate which is the best one in the order, least, the less result comes the last, why it is coming this, you write on that discussion, uh, citing the previous literature and your previous, what is the previous limitation, why you got better result, all these explanations has to come. And if your result is negative in 2, 3 findings, then why it is negative, you have to say whether the parameters you chose were different in that you couldn't get, or suppose example, organic reaction, we use some reagent. So maybe the reagent I used was not effective, or maybe I have used the less proportion of reagent, or when I use more, I'm trying to heat, it is not coming. Maybe other reagents I have to try, like that. Okay. So limitations you have to discuss, why it didn't come, and when you got the good positive results, the literature where they have the limitations in this found in this study, that will be advantage for you to write why your hypothesis is correct, why your research findings are correct, citing the references one's limitation. But his result should be less than yours. That is, your result should be better result compared to the reported in literature. You have to say so and this, so this person. I will say David et al. Reported the conversion of benzene to cyclohexane was 35. We report in the new finding that we got a result of 85% conversion. From this, conclude that this is a green process. Okay, so like this you have to write. Then you quote your references. Okay. So it is generally recommended that you report the effect size, so value test statistics, that is p-value, it is coming, and an alternative to report confidence in